This is Mr. Martin. These are the video notes for section 3.2. This is video number 3 of 3. So we're going to look at a couple of examples of proving triangles congruent. Again, we learned in one of the other videos that really we only need 3 pieces of information, not 6 pieces of information. So let's go ahead and get started. We've got 2 pieces of given information, so let's go ahead and get those into our proof here. So I've got that M is the midpoint of XY. That's given. And we have that XZ is congruent to YZ. That's also given. So at this point I usually like to mark any congruencies in my picture so I can see that I have those two things congruent. So most of this class, when we're doing proofs especially, is going to be drawing conclusions from things that we know are things that are given. So based on the information that's given, if I know that M is a midpoint, I know that XM is going to be congruent to YM. So let's go ahead and put that in our proof. We've got XM congruent to YM. And you notice how I named these in a corresponding order because we're trying to get these two triangles congruent. And like I mentioned before, the corresponding order that I name these is going to be important to us. So if a point is a midpoint, then it divides a segment into two congruent segments. Alright, so in order to get the triangles congruent, we're going to have to use one of our 3 methods. We're either going to use side, 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 angle, side, or angle, side, angle. So we can see already that I have 2 pair of congruent sides, so we're probably not going to use this one. If we're going to use side, angle, side, I would need angle X and angle Y because those are the included angles. And at this point, we really don't have a way to do that. Eventually we will have a way, but at this point we don't. But I can see that ZM, which goes down the middle here, is part of both triangles. So what I'm going to do is I'm going to use that as a reflexive side. And in my proof, the way I do this is I say that ZM is congruent to ZM. Alright, and all we need to put here is reflexive property. Alright, so we have another exception to our conditional statements. For this, we don't have to write it out in if-then form. If you want to, you can, but you really don't have to. So now we can see I have a pair of sides over here, I have a pair of sides over here, and I have one more pair of sides over here. So now I have enough to prove that our two triangles are congruent. So triangle XMZ is congruent to triangle YMZ. And our reason for this is side, side, side. And what we want to put in parentheses, which I mentioned in the other video, are the steps where you have your 3 pairs of sides congruent. So that's step 2, step 3, and step 4. Make sure you don't forget that. And then, labeling these with whether they're a pair of sides or a pair of angles that you're using to get your triangles congruent, that's optional. I like to do it because it makes it easier when I go back to figure out the numbers. Alright, make sure you write down any questions, ask me in class. Moving on to example 2, if you want to give this a shot on your own, and then just restart the video and see how you did. So we've got 2 pieces of given information, angle 1 congruent to angle 6, and BC congruent to segment EC. And again, we're trying to prove that these two triangles are congruent. Given, given, and let's see, I've got 1 congruent to 6, and I've got BC congruent to EC. So far, I've got 1 pair of sides in these two triangles, so I'm going to mark that with an S. And if I'm thinking ahead, since 1 and 6 are congruent, I can get 2 and 5 congruent either by supplements or by subtraction. I'm going to use subtraction. And then I see that 3 and 4 are vertical angles, so I can also get those congruent. So I can get these two triangles congruent by angle, side, angle. So we've got to get all that stuff into our proof, and it's going to take us a few steps. So the first thing that I'm going to need are a couple of straight angles. So I've got angle FBC and angle GEC are straight angles, and that's assumed from diagram. And then since they're straight angles, I know that they're congruent, so angle FBC is congruent to angle GEC. If angles are straight angles, then they're congruent. And now I can subtract the angles in step 1 from the straight angles to get angle 2 congruent to angle 5. Again, you can use supplements if you want to. I just prefer to use subtraction. So if congruent angles, that's angle 1 and angle 6, are subtracted from congruent angles, then the differences are congruent. So now I've got 2 congruent to 5. Alright, so now I have a pair of angles and a pair of sides. Here's a pair of angles. And I just need my vertical angles. So remember to state that they're vertical angles. Angle 3 and angle 4 are vertical angles. That's also assumed from diagram. Once we know that they're vertical angles, we know they're congruent. Angle 3 is congruent to angle 4. If angles are vertical angles, then they're congruent. Okay, so that gives me another pair of angles. So I see I have my 2 pair of angles in step 7 and step 5, and I have my included sides. Let's go back and double check here. Here's angle 3. Here's angle 4. My side is in fact included between the 2 angles. So I can prove that triangle ABC is congruent to triangle DEC by angle, side, angle. And again, you want to put the steps where you have all your different parts. So I have step 2, step 5, and step 7. Moving on to the third example. Remember, just pause and rewind as needed. Alright, so let's see. The 2 triangles that I want to get congruent are FJK, and HGM, And let's take a look and see what I've got congruent so far. I have JH is congruent to FG, and angle HKF, this angle here, is congruent to FMH, this angle here. So I can see right away that I can get these inside angles congruent by subtraction or supplements. And I've got KJG, I've got this angle here congruent to MGJ, this angle here, and I've got JGH, so this angle congruent to FJG, which is this angle here. And we know that K and M are also midpoints. Okay, so keep in mind that this is actually midpoint used 2 times. So possibly multiplication or division. Okay, so let's kind of talk through this proof here. Since I know that these two larger segments are congruent, and I know that K and M are midpoints, I know that JK and GM are going to be congruent by division, so that gives me a pair of sides. I can add the angles in the corners to get the big angles congruent, so that would give me a pair of angles, and then I could get these inside angles congruent by, again, supplements or subtraction, because I know the outside angles are congruent, and that would give me enough for angle side angle. So I'm going to go ahead and pause my video and write in this solution. If you want to go ahead and try and do it as well, pause the video, and then when you restart the video, the solution will be there, and you can compare yours and see if you got it right, and see if you have any questions. Okay, so here we ended up with 11 steps. 5 of them are given, so you know, really we only have 6 extra steps, but one thing I want to point out also is that I labeled a couple angles in the triangles, angles 1 and 2, just to make it easier to name them in the proof. So we've got that JK is congruent to GM by the division property. If segments are congruent, then they're like divisions are congruent. And then if we add the angles in the upper left and bottom right corners, we're going to get angle KJF congruent to angle MGH. If congruent angles are added to congruent angles, then the sums are congruent. Then we have to get angle 1 and 2 congruent, so since I know those big angles on the outsides of the triangles are congruent, I could use subtraction from straight angles, so I need to state the straight angles in step 8. That's assumed from diagram. Then we say that the straight angles are congruent. And if you're going to use supplements, you don't need step 9, but you would need 2 other steps to state the supplements on the top and bottom. And then by subtraction, we're going to get angle 1 congruent to angle 2. If congruent angles are subtracted from congruent angles, then the differences are congruent. And then you notice I have A and S by the appropriate steps, so it made it easy when I went back to figure out the steps to put in my final conclusion. I've got triangle FJK is congruent to triangle HGM by angle side angle, and the steps I used were 6, 7, and 10. So go ahead and pause the video and make any corrections you need to. Write down any questions. Make sure you ask me in class. Again, if you can't prove triangles are congruent, you're going to have a really hard time being successful in the class. So make sure you get any questions that you have answered right away. Make sure you use the class time appropriately and effectively to work on practice problems and get help. We'll see you soon.